Right guys, good evening. Starting the new session. So we discussed about the accelerating system and we discussed how to find the tension of accelerating system, right? And we finished it. And that was under the pulling, right? When a system is pulling with a force, and we found the acceleration of the strings, right? Of the strings which are attached to the objects, right? So now the second part of that, it's the same theory that comes under the like the accelerating objects, right? So this is the same theory when you are applying. What did we do when we are doing the when you are finding the tension of the rope? First thing we found the acceleration of the whole system. Yes, and then yes. So first thing we found the acceleration of the whole system by putting sigma f equals ma. Second thing is we isolated the object and we derive the forces, right? And the last thing was we put the sigma f equals ma to the isolated object and found the unknown force, right? So it's the same thing that we are doing when the system is accelerating. Remember, when a system is accelerating and you are asked to find any of the forces, so same thing you have to do, right? So now the starting from the seventh, find the tension of the strings, right? So the first one, string at rest. String doesn't move. String at rest means like the object doesn't move, stationary. So what happens? If something is stationary, it should be under equilibrium. If we consider the forces, upward forces should be equal to the downward forces, and the left hand side forces should be equal to the right hand side forces. That means the x axis and the y axis. So there is no any forces in the x axis, only the forces acting in the y axis are there, right? So what are the forces acting here? Yeah, so 100 newtons are acting downwards as the weight, right? And the tension should be acting upwards. Yeah. So since the system is under equilibrium, the weight should be equal to the tension, right? So the tension equals 100 newtons, right? And I ask you to do this like try these questions at home, right? I did. Correct. Nice. Right. Come to the second question. System moves down in an acceleration of 2 ms minus 2, right? System moves in acceleration of 2 ms minus 2. Tell me what happens now. Let's think of something like this. Like think that you're attached to a string with your wrist and you're moving the object with the acceleration. Like make a downward acceleration. String you are taking down, you're like a string attached to you, an object is there, right, with a mass, and you're moving the whole system with a 2 ms minus 2 acceleration downwards, right? Right? So what would you feel on your wrist? Would the tension be increasing or decreasing? Have you ever feel it like have you tried it dropping? No? You are just moving your hand with the system giving acceleration downwards, that's all. Oh, string you are taking the whole system down with the acceleration. What happens? Arduino. The experience is Arduino. If you have done it, Arduino. And the same thing when you are in a lift, that we did one of the practicals, the experiments in Havelock, right? In Havelock we did an experiment. What happens when you are in a lift? You are accelerating downwards. How would you feel your weight? We losing or gaining? Losing, right? When you are going down in a lift with the acceleration, you feel like losing weight, right? So the same thing, when a system is moving downwards, the tension will feel less. So how do you calculate it? Same thing like the pulling system. First you find the acceleration. Now you don't have to find the acceleration because the acceleration is already given. So what's next? You isolate the object and mark the forces, right? You isolate the object and mark the forces. Right, you isolate the object and mark the forces. How do you mark the forces? So 500 newtons acting downwards, right? 500 newtons acting downwards and the tension acting upwards, right? That's all the forces. And the acceleration is how much? 2 ms minus 2 downwards, right? Downwards. Now you have to find the tension. How do you find the tension now? Oh, what happened? How do you find the tension now? Huh?
Sigma F equals
Yeah, you have to put sigma F equals ma, right? Sigma F equals ma to the isolated object. I had to put sigma F equals ma. Now what is the sigma F here? Sigma F.
Newton minus T.
Yes. Why do you take 500 newtons minus t? Yes. Yes. ඒ කියන්නේ මේකේ resultant එක තියෙන්නේ පල්ලෙහාට. මොකද ඒ පැත්තටනේ acceleration එක තියෙන්නේ. නේ? The acceleration is downward because the resultant is downwards. That means the downward force is greater than the upward force. So you have to deduct the lower, like the lesser force from the greater force, right? So you have to deduct 500 newtons from you have to deduct T from 500 newtons, right? Equals mass is 50 kilograms and the acceleration is given 2 ms minus 2. Now simplify and find the T. You get 100 here, minus T taken there, it becomes plus T. 100 newtons coming to this way becomes minus 100. T equals 400 newtons. What has happened? So if it was in the stationary phase, the tension should be equal to the weight, no? So it's 500 newtons when it's stationary. And what happens when it moves in an acceleration downwards? The tension has reduced, right? It's supposed to be 500 when at rest. Now it is 400 when it is moving downward in acceleration. So downward acceleration gives a reduced tension. Get it? Same happens in the acceleration, like in the elevator. When you are going down, the weight feels less, right? Got this? Right. Shall we go to the next? Yeah. Oh, that's the next question. This question. Oh.
50 kilograms පෙන්නවා කියන්නේ.
Oh.
දැන් උඩට යද්දී ඒක වැඩි වෙනවනේ.
Oh.
ආයේ පල්ලෙහාට එද්දී 50 ද පෙන්නන්නේ නැත්නම් 50
50 වලට අඩුයි.
අඩු ගන්න.
50 වලට අඩුවෙන් පෙන්නනවා. තීන weight එකකින් අඩු වැඩි 50 කට වඩා අඩුවෙන් පෙන්නනවා. මං හිතන්නේ උඩට යනකොට acceleration එක පොඩ්ඩක් අඩු කරලා යන්නේ පල්ලෙහාට යන acceleration එකට වඩා. එහෙම එකක් තියෙනවා. ඒ කියන්නේ මේ elevators වල එහෙම හදලා තියෙන්නේ. ඒකින් තමයි අපිට අර ලොකු change එකක් පේන්නේ නැත්තේ. පල්ලෙහාට යනවා කඩාගෙන උඩට යන්නේ හිමි. ඔය පල්ලෙහාට එන එක ලේසියිනේ. නියුට්‍රල් නේ.
පල්ලෙහාට ගිහින් නවත්තනකොට පොඩි බෑනවා මේ අඩු කර ගන්නවනේ.
ඔව්.
රේට් එක නැත්නම් එකපාරට බලන්න
බෑනේ. ඒක තමයි. අඩු කරගෙන ඇවිල්ලා එකපාරට නතර කරගන්න. අර උඩට යනකොට මං හිතන්නේ slow යන්නේ ඒකින්ද weight difference එක ලොකුවට පෙන්වන්නේ. Right. Come to this question. Now can you do it by yourself? Make a lazy. Kida. So that's the question you asked, right? You already have answered it. උඩට යනකොට tension එක වැඩි වෙන දානවා දැන් question එක කළා. That's the thing. නේ? You understood it, like you have done the question anyway but haven't understood what happens, right? And that's one thing. You have to understand the real case scenarios. That is why you are learning this, right? When you are working somewhere, you'll be applying these things. Only you can apply it when you understand how the thing works really. ඒ වගේ මම දැන් මේ ටිකේ බලන්නකො. Right? So how do you do this? So you have the acceleration, so you don't have to put sigma f equals ma to the system to find the acceleration because it's there already. So the next thing you do is you isolate the object. 500 newtons acting downwards, right? And a tension acting upwards of a T, and the whole system is going upwards of a 2ms minus 2 acceleration. Yeah. So put sigma f equals ma to the isolated object. Now which force is greater, T or 500? T is greater, so T minus 500 newtons equals mass is 50 kilograms. Now the acceleration is 2ms minus 2. So it's 100. You take the minus 500 to that way, becomes plus 500. Adding together becomes 600 newtons of a tension. So what has happened when you are moving up in an acceleration with a like a rope? The tension increases, right? අපි wrist එකේ මොකක් හරි rope එකක් ගැට ගහලා, do you have anything? Bottle එක තමයි sacrifice එක. Only the bottle is there to sacrifice. නූලක් තියෙන උත් නැහැ. දැන් මේක මම දැන් මගේ මේකින් tension එක එන එක මට දැනන්න ඕනේ ඇඟිල්ලට. මම මේක මෙහෙම පල්ලෙහාට ගෙනිච්චොතින් I'll be feeling less tension to my finger. Get it? And if I move this upwards in an acceleration, I feel more tension to my finger. That is there. Right? Try color bar. Yeah. You have a rope. Try it. With the acceleration though. You have to do it with the acceleration. Palleyata gicchothin adui. Udata genichothin adui. Try it at home. Don't do it here. Right. So the next question. Two weights hang on a frictionless pulley. What happens here now? Two weights. Now tell me, this is the question. Now there are two weights, right? 10 and 20 kilograms. And the system has to move one direction, right? So tell me when can you tell me which direction would the system move? Towards the 20 kilograms Newton, or like the 20 kilograms side or the 10 kilogram side? 20 kilogram side usually, right? Because the 20 kilogram weight is greater. And now tell me if the 10 kilogram is supporting the movement or opposing the movement. Is it resisting or supporting it? Supporting or resisting? Supporting. Resisting. The boy is saying resisting. Supportive. Who? The weight. Now the weight actually isn't supportive here. Have you tried? You don't usually try something like this, right? Something that tell me something happens like this. Kambadi no, we don't use a pulley. Oh. හරි ලින්දෙන් වතුර අදිනවා ගන්නකො ඒ වගේ එකක් no. Now think of this. Let's say if I keep the 20 kilogram object only and I put the rope over the pulley and I release it freely, can you imagine the speed now? It will be speeding, right? And now in the second one I'll be attaching one of the 10 kilogram weights in in one side the 10 kilogram weight and the other side the 20 kilogram weight, and I'll be releasing it freely now. Would it move fast or would it move slow? Now it becomes slow, right? So what has happened to the movement? It's been resisting, right? It's been acting oppositely. That is why it is slowing. Get it? So the 10 kilogram is acting oppositely, right? That's what's the importance of the pulley. Pulley can show like the forces are acting towards the same direction. Like if I draw the forces here, both the forces are acting the same direction, right? But in real case, when it's moving, the forces are acting oppositely. This seems like acting the same direction, but because of the pulley, the forces are actually acting oppositely. It is like if you straighten the rope. If you straighten the rope like this, so this 20 kilogram is acting towards my right hand side and the 10 kilogram is acting left hand side. So they are acting oppositely. So if you are using a pulley, think of like that. You have to straighten the rope and see how where the forces are acting. They are acting always oppositely. So this one is greater, right? 200 newtons are acting downwards here. 100 newtons are acting downward here, but they are acting oppositely in the real case, right? So now we have to find the acceleration of the system, right? First, before finding the tension, you have to find the acceleration. So finding the acceleration, you have to put sigma f equals ma to the system. Now tell me what is sigma f here?
200 minus 10 minus
Yes.
200 minus 100.
Yeah, 200 minus 100. Yes. So 200 is a greater force, the 100 is a lesser force, right? And they are acting oppositely. So the sigma f equals ma is 200 minus 100 newtons equals to mass into acceleration. Now do we take the mass of the whole system or only one mass? You have to take the whole system because we are putting in the putting the sigma f equal to find the acceleration of the system is to the whole system. So we have to take the complete mass, right? So what is the complete mass? 30 kilograms and find the acceleration. So what is the acceleration now? 100 over 30, right? Which is how much? 3.33 ms minus 2, right? 3.33 ms minus 2. Got it? Right.
ඊට පස්සේ separated 20 right entire.
එකකට දැම්ම නැති. එකකට දැම්ම නැති. Same rope නේ. Because the pulley is frictionless. So same rope have same friction. Right? එතකොට අපි මෙයාට දාලා ටෙන්ෂන් ගත්තත් මෙයාට දාලා ගත්තත් එකම ටෙන්ෂන්. ඕනනම් දෙකටම දාලා බලන්න පුළුවන් will be the same tension. Do you get it? Now remember this. But if it is the same rope, it has to have the same tension. Get it? If it is the same rope or the same string, it has to have the same tension, right? Acting oppositely, right? And since this is a pulley and the pulley says it doesn't have any friction, that means the tension are still equal, right? But if there was any friction in the pulley, the tension will change in the either sides. Get it?
ඒ කියන්නේ මේකට යන්නේ.
නෑ it's මේක අර වගේමයි. ඒ කියන්නේ අපි අර කලින් ගත්ත මේ සිස්ටම් එක මෙන්න මේක ගත්තේ. මේක වගේමයි. Think about the first one. මෙන්න මේක වගේමයි. Only difference is මෙතනින් පුලි එකක් දාලා තිනවා. දාලා මේ දෙක. So no friction. ඒතර එකම වගේ. Get it? එකම වගේ. No difference. හරි. So now find the tension. You have to isolate one of the objects. Which one would you isolate? 10 or 20? Select one. 20. 20. Then 20 it is, right? So 20 kilograms are there. 200 newtons are acting downwards. Isn't it? Huh? Right? 200 newtons are acting downwards and tension is acting upwards. We found the acceleration. Now the acceleration is this way. Here it's downward, here it's upward. Get it? මෙහි upward and acceleration මෙහි යන්නේ but the same acceleration. මෙහි upward and මෙහි downward. So when you are putting the object, now when you are selecting the object, the acceleration direction changes. මෙහි උඩට යන්නේ මෙහි පල්ලෙහාට යන්නේ. So I selected the 20 kilogram one, so the acceleration is downwards. 3.33 ms minus 2. Now put sigma f equals ma. Sigma f equals ma to the isolated object. Tell me what are the sigma f? 200 minus t, right? 200 minus t equals mass into acceleration 20 kilogram into 3.33 ms minus 2, right? So tell me what is 3.3 into 20? 33, 66.6. So minus t going that way, that becomes plus t. Metana t equals 200 minus 66.6. Tell me the answer. 1. What is the answer? 130.4 newtons. It will be the same if you put to the 10 kilogram weight as well. But when if you are putting to the 10 kilogram weight, the acceleration is upwards, right? Because the object is moving upwards and the tension is greater than the weight. Get it? Here the weight is greater than the tension. That is why it is moving. Get it? Think of it. You will understand. Right? You will get it. Right? Got it? You want time to write it? Or not? Right? Did you write it? Already did it? Then fine. Right. Then come to the next question. Shiny, did you write it? If you want time, just put a text. Right. Come to this question. Lifting a force by a pulley by applying force. Right. You are to lift this weight by applying a force. So how much of a tension would come to the rope? No acceleration. You are just holding it. Right. Make a holding now. Right. Make a holding now. Oh, දීලා නැහැ. දීලා නැත්තන් නේ. එතකොට එතකොට මේකේ පල්ලෙහාට 400 and the tension will be same, right? And here the tension will be also same, 400, because it's stationary, right? Upward forces should be equal to the downward forces, and so here the tension should also be 400 newtons, and the applied force also should be what? The applied force should also be 400. මෙතන applied force එකත් එක්කින්ද 400 newtons වෙන්න ඕන. එතකොට මේ ඔක්කොම equal වෙන්නේ stationary වෙන්නේ. get it? මෙයා 400 නම් මෙතන tension එකත් 400 වෙන්න ඕන stationary වෙන්න. මේ එකම string එකේ හින්දා මෙයා 400 නම් මේ පැත්තේ tension එකත් 400ම තමයි. right? ඒ පැත්ත tension එක 400 කියලා කියන්නේ අපි මෙතනින් ඇදගෙන ඉන්නෙත් 400 newtons වලින් තමයි.
එතකොට සර් පුලියගේ friction එකක් තිබ්බොත්
එතකොට වෙනස් වෙනවා.
මොකටද දෙත් කරන්නේ?
අපි නෑ ඔව් ඒ කියන්නේ අපි ඒක ඒතර ඩිරෙක්ෂන් එක බලලා ගන්නවා. දෙපැත්තටම වෙනවා ෆ්‍රික්ෂන් එක. ඒතර ඒ දෙපැත්තම කන්සිඩර් කරලා ගන්න ඕන.
එහෙම ගණන් තියනවා.
නෑ. ඒ කියන්නේ ෆ්‍රික්ෂන් එක චේන්ජ් වෙනවා ටෙන්ෂන් දෙකක් එන්නේ. මෙහෙට එන එක ටෙන්ෂන් එක අනිත් පැත්තට තව ටෙන්ෂන් එක. ඒ වෙන්නේ. Nothing to worry about. Right? Come to the next question, this one. Now this is another theory you have to understand, right? Done? Yes? This is another theory that you have to understand. Tell me this. Now this system, a weight on a smooth surface tied to another weight using a pulley, right? So no friction is also there, right? No friction there. Bros, listen. No friction there, right? So now tell me, would the weight of this object affect to the acceleration of the system? I'm asking the weight. would the weight of this system affect the acceleration of the system? Yes or no? Tell me something. Yes or no? Weight of this 10 kilogram object, would it affect to the acceleration of the whole system? Would the 20 kilogram of mass or the 200 newtons of weight affect the acceleration of the system? Yes, because it's the force like driving the whole system, giving the acceleration. Would the 10 kilogram affect that? I'm not asking the 10 kilogram mass, I'm asking the 100 newtons of weight, would it affect or not? Why not? Because මේකේ weight එක act කරන්නේ කොහෙටද? පල්ලෙහාට 100 newtons. And since there is a surface, there will be a reaction upward that should be also equal to 100 newtons, so they cancel out and no any resultant there, right? And also now if you take this 20 kilogram of a weight, it gives a 200 newtons of a force downwards, right? 200 newtons giving downwards, right? So if this is stationary, the tension will also be 200, right? And the tension here will be towards this way and it will also be 200. Get it? Now the force applied from this one is acting in the where? Which axis? X axis here, right? And the force here is acting in the y axis. And can a force in the x axis affect a force in the x axis? No. Why not? Because there are no components in 90 degrees, right? 90 degrees වලින් components නැහැ. අපි අර resultant force එකේ components ගන්නවනේ. ඒකෙදි අපි 90 degrees වලට components ගන්න පුළුවන්ද? බෑ නේ. මැදක ඉඳන් අර 90 degrees වලින් අඩු තියෙන මොකක් හරි angle දෙකකට තමයි අපි components ගන්න. right? ඒකත් මතක තියාගන්න. හරිද? මං කියප එක මොකද්ද? 90 අපි අර කලින් එකෙත් කතා කරා. ඒ කියන්නේ 90 degrees වලින් components නැහැ. ඒ කියන්නේ 90 degrees වල තියෙන එක x axis එකේ ගානට තියෙන එකක් y axis එකේ components වලට හොයන්න බෑ. ඒ කියන්නේ මෙයාගේ මෙයාට effect එකක් නැහැ. නේද? මේ y axis එකේ ඉන්න එකගේ x axis එකට effect එකකුත් නැහැ. right? හරි. එතකොට එහෙනම් මේ force එක මෙයාට impact කරන්නේ නැහැ. නේ? Get it? So if I put sigma f equals ma to here, that's it. If I put sigma f equals ma to here, what is the sigma f here now? 200 or 200 minus 100? Just 200, because the 100 doesn't affect it, right? So it's just 200 newtons. What about the mass? So the whole system is accelerating. So should I take the 20 kilogram only or the whole mass? I have to take the whole mass, that is 30 kilograms into acceleration, right? So the first thing you have to find the acceleration. So how much is the acceleration? 200 over 30. How much? 6.66. So it's 6. What's happening? 6.66. Right. ms minus 2, right? ms minus 2. So this acceleration is downwards, right here. Now you have to find the tension of the rope, right? Tension of the rope. To which object would you put the F equals ma? 20 or 10? Isn't 10 easy to put with or anything? You have to consider two forces in the 20. 10 there's only one force. 10 is easy, right? So I'm isolating the 10, and the tension is here, T. Is the same tension, right? And the mass is 10 kilograms. If I put F equals ma, so the F is now T, because the tension is the driving force, and the mass is 10 kilograms. Acceleration is 6.66 ms minus 2. ms minus 2, right? How much you get? 66.6 newtons. Yeah. The same answer will be there if you put the sigma FMA to the 10 kilogram. It will be same. Understood? Stood well? Oh, what's happening? Done. Yeah. Right. Now this is a new part. So you are supposed to do this at home. Hands up those who got all the answers correct. Nice. Johan? All the answers correct? Cool. Megat. What happened? Megat gattad? ඒක අඩු කරා. that's a new theory. ඒ වගේ පොඩි පොඩි theories එකතු වෙලා තමයි ඔක complex වෙන්නේ. ඒ වගේ තව තියෙනවා අපි will be discussing more questions in the future. Force questions we'll be discussing. And I have given you the orderly tute, right? Yeah. And if you are to, I think I have put the video of the the answers, like solving the answers. I have put a video in the YouTube. Just go search after finishing the tute, not before doing it. Huh? I think not reason. Maybe. බලන්න එක. ඒකේ තියෙන ඔය ටික questions. ඒකේ තියෙන ටික තමයි. playlist එකට add වෙලා නැද්ද දන්නේ? බලන්න ටික videos වල අඩියට ගියාම පස්සේ ඇති. should be there. tute එක complete කරලා ඊට පස්සේ බලන්නේ. ඊට කලින් බලන්න ඉපා තේරුම් ගන්න. හා? Yeah. So like do it by yourself, struggle a bit, have time trying to go through the questions, take time as much as possible, that's fine, and like do it by yourself, try to understand it by yourself and apply it with the knowledge. Otherwise අර නිකන් මේ ටික පාඩම් කරලා තේරුම්න්නේ. You have to struggle it. මේක පොඩ්ඩක් බැරි වෙන්න ඕන. බැරි වෙලා you have to try it again. And you have to ask the people. Now your friends are here. You can ask these people as well. Many of them are teachers. They are teaching each others. So you will be getting a better lecture. Sometimes maybe better than me, because I am not in your level. So in your level maybe you'll be solving problems sometimes better. ටිකක් බර එකක් આવොත් මට දානවා. එතකොට මට solve කරන්න පුළුවන්. හරි. අර පොඩි tips යන ඒවා ඕගලන්ගේ level එකකින් තමයි හොඳටම කරගන්න පුළුවන්. That's one advantage of like studying together. අර එකට වැඩ කරනකොට තියෙන advantage එක තමයි ඒක. අර පොඩි ඒවා ඕගලන්ට ඔලුවට දාගන්න ලේසි. අර බර ඒවා තමයි ටිකක් මට අදින්න හොඳට set වෙන්නේ. Right. Now this thing. Equilibrium of forces, right? So if an object to be under equilibrium, there are two things that you have to consider, right? Listen carefully, this part is very important, and these questions coming next are a bit tricky, so you have to really focus and really understand how the thing works, right? So this is the theory. If an object is under an equilibrium, there are two things to consider. One is the equilibrium of the forces, which means yes, resultant force should be 0 in the vertical and the horizontal axis. Again, upward forces should be equal to the downward forces, left hand side forces should be equal to the right hand side forces. That is one. What is the second thing? Second thing is the object should be under an equilibrium of the torque or the moment, right? That means the resultant moment should be 0. Get it? That means there can't be any left hand side rotations or right hand side rotations, right? The addition or the algebraic sum of all the clockwise and anti-clockwise moments should be 0. That means resultant torque should be 0. Get it? Right. So you have to consider that. So if you are to find the force, find a force of a stick which has many forces like this, and the question says it's under equilibrium, right? There's a method or a way of doing it, right? Try to practice this, try to remember this. It's like the systems that are accelerating, that there was a process to do it, steps to do it. So same like here, there are steps to do this, and you have to remember the steps, right? Remember the steps and follow it, will be easy to do the calculations. So this is the thing, right? So if an object is or a stick is under equilibrium, it says when you are taking the torque at any point in the stick, let's say this one, you can take the pivot point at any place. You can take the pivot point from this point, even from this point, even from this point, the given point, or any point you want, and you add all the clockwise and anti-clockwise moments, right? And the result will be 0. I am telling it again. If an object or a stick is under equilibrium, you can take the pivot point at any place. Methenin pivot point එක ගන්න පුළුවන්, methenin pivot point එක ඕන තරකින් ගන්න පුළුවන්. Now if you take the pivot point here, right? If you take the pivot point here, now the force towards the 20 newtons, distance towards the 20 newtons force, and if I take the pivot point from here, now the distance toward the 20 newtons are different, right? Right. But still, if you take the sum of all the clockwise and anti-clockwise rotations or the moments and add it together, though they have the different moments to the different forces, the final result will be 0. Get it? කොහෙන් ගත්තත් ඔයාට resultant moment එක 0 එන්නේ. දිගවල් වෙනස් වෙන්න පුළුවන් ගන්න තැන අනුව. But when you add it all together, the final answer will be 0. Remember that, right? So you'll be considering that theory when you are doing the calculation. You got it? You can take from any point in the stick and add all the left hand side and right hand side or the clockwise anti-clockwise moments, and the final resultant will be 0. Get it? Right. So when you are finding the resultant that way, this is how you do the calculation, right? You can't take like this. මේ මෙතන pivot point එක දීලා තියෙනවා, that's fine, and you can't take it like this. මෙයා ගුණ කරනවා මෙයාගේ, මෙයා multiply කරනවා මෙයාගේ, and you equal it. You don't do it now then, right? Were you doing it in your O levels? I think yes. Yeah. F1 this one equals F1 this one, right? You don't do it now, right? So it's a different case now, right? So how do you do it now? You take it this way. How? You take the sigma tau equals 0, which means there's no resultant torque. There's no moment towards anywhere. Get it? And you equal it to 0. Now the 0 equals, you take the left hand side rotations first and take all the left hand side rotations plus values, right? Take the left hand side rotations first and take them as plus values. This is just a method, just a method, not a hard and fast rule, just a method, right? So take all the left hand side or the anti-clockwise rotations plus. So tell me the anti-clockwise rotation here now. F force in 6 meters. So F into 6 meters. And take all the clockwise rotations or right hand side rotations as minus values, right? So what are the right hand side rotations here now? 3 newtons into 4 meters. You take them as minus values. 3 newtons into 4 meters, right? And you equal it to the 0. Now you simplify this. What do you get here? 6F minus 12. Take the minus 12 to the other way, it becomes plus 12. So 6F equals 12. Cancel out it. F equals 2 newtons. Get it? Same way, this stick is under an equilibrium and the pivot point is given. So take the pivot point here to this question and find the unknown force F. You know how to do it now. How do you do it? First thing to write is sigma tau equals 0, and you equal the 0 to first you write the clockwise rotations as plus values, and then you deduct all the right hand side rotations giving minus values, and you get the resultant finally. Not the resultant, the unknown force finally. Do it. I'm only giving you like 2.5 minutes. Do it fast. Now the clock is ticking. 2.5 minutes. Huh? Do it fast. Use a paper. Do it again. Done. Nice. You remembered it or you?
Thank you.
How's it going? Tell me an answer. Yeah? Yes. Right? Right. Finish. So, what is the answer? 10 newtons, right? 10 newtons. Okay. So, I'll do it. Sigma tau equals 0. And 0 equals, I'm taking the left hand side rotations first. Now this is left hand side rotation F, and the distance is 10 meters. So F into 10. And what else are acting the anti-clockwise direction? This one is also acting the anti-clockwise direction, right? And it is also in 10 meters. So plus 100 Newton into 10. All the others are minuses because all the others are acting the clockwise direction. So this is 5 meters, 20 newtons. 20 Newton into 5 and put a minus again, and this one 500 in 2 meters. I don't have enough space, right? I'm going to write this down. 500 into 2. So simplify the values. 10F plus 1000 minus 100 minus 1000, right? So this plus 1000 to minus 1000 cancels out. Minus 100 coming to this way becomes plus 100. So 10F equals 100 and F equals 10, right? 10 newtons. 10 newtons. 10 newtons. Shiny, can you hear? Shiny calculations කරන් යනවනේ. Yeah, done. Done. ඒ ටික ලේසියි. මේ ටික ප්‍රැක්ටිස් කරපුවාට මේ ටික ලේසියි. දැන්ද පැක් වෙන්නේ හරියට. ඉස්සර ලාවට තේරුණා දැන් පැක් වෙනවා එහෙමද නෑ. නෑ නේ මේ ටික ලේසි. Right? This one. හරිද? ඔන්න time on. Now this one is another theory. This is also important, really important. Right? Ah, yeah. You're doing the questions, right? Good. Right. This one is really important. Now listen. The pivot point here is given, but don't take that. Right? Don't take that. Now, because if you take the pivot point here, what happens? There are two unknown factors, two unknown forces, right? So if there are two unknown forces or factors in a formula, you can't get it into one answer, right? Because there are two unknown factors. So you have to remove it. When there are two unknown factors, usually what do? You have to learn these things and remember these things. These are really important. When there are two unknown factors, there are things that you can do. The first thing is you can put a simultaneous equation and remove one factor and isolate the other factor and get the answer. That is one thing. Or else, like in these cases, we discuss something, like we discussed two theories previously. I said that you can take the pivot point from any of the places on the object or the stick. Did I say it? I told you like you can take the pivot point from any place on the stick and calculate the resultant torque will be 0, right? Adding all the clockwise and anti-clockwise moments, the final answer will be 0, right? And there is another theory we discussed really previously, I think page number 7. Yes, page number 7. Can you come to the page number 7? This is page number 12. Oh, going page number 12. Yes, sir. Did I cancel it? Yeah, I think yes. Oh, cancel. Give me a second. Cancel. Right, page number 7. Page 7. This one. This is page 7, right? Ah, no, 10. Page number 10, right? In the page number 10, we discussed that the force acting on the pivot point doesn't affect the moment. Can you remember? Yeah. Force acting on the pivot point, that if we take the pivot point as A, the 100 Newton will give no effect on the moment. Can you remember, right? So this theory we can take it to the the questions when you are answering. That is why I gave you this theory here. Now this is a simple question, right? But the theory here is very important when it comes to the the bigger questions, right? So what is the theory here? The force acting on the pivot point doesn't affect the moment. Get it? The force acting on the pivot point doesn't affect the moment. So if you want to cancel out any of the forces in an equilibrium, what shall we do? What should you do? You should take the pivot point on that force, right? You should take the pivot point on that force. So where should you take the pivot point if you want to find the A value? Tell me, where should you take the pivot point if you want to find the B value, A value? If you want to find the A value, where should you get the pivot point? Where? FB, right? So if you take the pivot point from FB, so FB will cancel out. So the only unknown factor is FA, right? So take the pivot point from here. So FB will cancel out, right? So taking the rotations from FB, right? Taking the rotations from FB. Now write down sigma tau equals 0, right? And 0 equals whole thing will 0 equals, write down the anti-clockwise rotations first. What are the anti-clockwise rotations here? This is anti-clockwise, and what else? This one is also anti-clockwise. Only two are there, right? And is the mass of the object or the stick given? No, mass given. Then only two. Make I visceral. So this is 80 newtons. So 80 newtons acting in 3 meters, and this force 40 newtons, 3 meters, 7, 10 meters, 12 meters, plus 40 newtons acting in 12 meters. Yes, right. Now all the anti-clockwise moments are finished. Now the clockwise ones. Only FA is acting clockwise, right? So minus, it is acting in 10 meters, right? FA into 10 meters. So now only the unknown factor is FA, right? So simplify it, you will get the FA value. So tell me the values here. 80 into 3 is 240, plus 40 into 12 is 120, 480, 480, minus 10 FA, right? 10 FA. Now adding these two together, what do you get? 720 minus 10 FA coming this way becomes plus FA is equal to 720. Now it's equal to 72 newtons. 72 newtons. So the FA equals how much? 72 newtons. Got it? So how are you going to find the FB value now? Either you take the, now you can, since you know the FA value, you can take the pivot point from anywhere and find the FB value. And there's another method of doing it. We discussed in the like the starting that if an object is under equilibrium, there are two things to consider. One is the equilibrium of forces, the other one is equilibrium of torques, right? Now we considered the equilibrium of torque and found the answer of FA. Yes. Now if you want to find the FB value, now you can consider the first theory, what? The equilibrium of forces. That means upward forces should equal to the downward forces, right? So there are no any left and right forces, so nothing to worry about it. And if you consider the up and downward forces, so downward forces are what? This is 80, this is 40, right? Other than that, any of the forces acting downwards? No. So that's altogether 120 and should be equal to the forces acting upwards. So we found that FA is 72, then FB should be how much? You have to calculate. So these are the downward forces, they should equal to 72 plus FB, right? 72 plus FB. Now tell me the final answer of FB. This is 120. 120 should be, like 72 should be deducted by 120. How much? 98. 48, right? 48 newtons. Yes? 48 newtons. Now there's another guy joining. Pass me. Bro, who's this pass me? I'll pass you if you continuously come to the class. Pass me. Put send me your name. Is it Rakif? Is he? I don't. Pass me. Bro, send your name. Who's pass me? 1211. I don't think Akif is busy with the wedding. Oh, who gave in the kid? Bro, things are recording. Yeah, got it? You want time to simplify? On? Liver? You haven't done? He went. හරි ඉවරද? No, I don't think so. But right. Come to this question. Now put the value here, 30 degrees. Okay. This is 30 degrees. Right, 30 degrees. Angle here is 30 degrees. And you are asked to find the tension, and the system is under an equilibrium. How do you find the tension? Now this is one of the theories, best theories, you know. Now let's say, now this is one of the glasses in a building. Like in some building there's a like the huge glass there, like there's a huge glass in the entrance. Have you seen it? Yeah, like these kind of buildings, and they have like මෙන්න මේ වගේ glass එකක් දාලා තියෙනවා in the entrance. Now this is the building. මේ වගේ දැකලා තියෙනවා. මේ entrance එක ගාව මේ glass එකක් දාලා තියෙනවා, and the glass is held by kind of a or a string. Haven't seen it? මෙන්න මේ string එකෙන් තමයි මේක අල්ලන් ඉන්නේ. cable එකක් දාලා තියෙනවා. මෙහෙම cable එකක් දාලා මේ cable එකෙන් තමයි මෙයා අල්ලන් ඉන්නේ. cable එක මෙන්න මෙහෙම ගැට ගහලා තියෙනවා. Right? And now you are given to do this job. Right? මෙහෙම cable එකක් දාන්න දෙනවා. So you have to know the weight of the glass, and you have to know how much of a tension will come to the cable. And depending on that, you have to decide how much of a girth should be there in the cable, how much of a strength can it be bared. You have to calculate and you have to understand that. And depending on that, you have to select the cable. Otherwise, නිකන් set වෙන්නේ නැති cable එකක් ගත්තොත් බඩු පැකට් පහ මෙතන පල්ලෙහා එන set එක කෙලිම crush වෙලා යනවා. So this is something like that, right? This is something like that. You have to you have to find the tension of the cable here, and the weights are given like this. This is 80 kilograms, and the weight of the pole or the mass of the pole is given as 20 kilograms. So there's a weight acting here apart from the 80 kilograms. So how do you do this? How do you find it? How do you find it? Bro, can't say it. Just have to try it. How do you do it? Yes. Component එක කරන් හදන්න ඕන. හරිද? Listen. How you simplify this? So here you have to consider, now first thing is you have to label the forces. What are the forces apart from these forces now? Now this here it's 800 newtons are acting, right? 800 newtons are acting here. And what else? There's a 20 kilogram of a weight, mass, and it's in the pole. And where should that 20 or the 200 newtons of force must be acting? In the middle. In the middle, right? Not in the pivot point. In the middle. Why? That's the question. Why? If මොකද්ද? Now the pivot point isn't this one. මේක නෙමෙයි. Better take the pivot point from here, or else you have to consider the forces acting here as well. මෙතනත් forces මොනවද තියෙනවනේ? You don't know those. So take the pivot point from here. Those will cancel out. Otherwise, it will be difficult, right? Now tell me, why is the weight acting in the middle of some objects, not all the objects? In some of the objects, the weight is acting in the middle, right? Now where's your weight acting? From which place? Where's your center? Yeah, the belly button, right? Your center of gravity is your belly button, right? So you can be balanced if you give a thrust on the belly button. You have no idea, right? සාමාන්‍යයෙන් මිනිස්සෙක්ව belly button එකෙන් අල්ලලා මෙහෙම balance කරන්න පුළුවන්. He can stay like අර මෙහෙම ඉන්න පුළුවන්. belly button එක උස්සන්නේ. ඒ කියන්නේ belly button එකට අත තියලා you lift the person so he can stay balanced like gymnastic, right? Why is that happening is because the gravity, like the center of gravity is there in the belly button. So all the forces, like the you know there will be no any resultant because the whole weight is acting at that point, right? අපි එක පොඩ්ඩක් හරි එහාට මෙහාට කරොත් මොකද වෙන්නේ? There will be rotations. Get it? පුළුවන්. මෙහෙම උස්සන්න පුළුවන්. එයාව තල්ලන්නේ එහෙම තමයි. නේ center of gravity එකෙන් අල්ලන්නේ. And that is because of all the symmetrical objects, right? Listen carefully. Symmetrical objects. You know the symmetrical objects, right? If someone is not symmetrical, they won't be balancing the belly button, right? If someone can't balance in the belly button, that means he is not symmetrical. Some part of his body must be greater than the other part of the body, right? Because if a symmetrical person is there, it has to be in the middle of the object, right? If someone is symmetrical, always if something, any object is symmetrical, the center of gravity should be in the middle. So come to this one. Now where's the center of gravity then? In the middle. That means the pole is 10 meters. It should be in 5 meters. Now how many newtons? 200 newtons, right? Should be in the middle. Get it? Right, now all the forces are there. Now if you put the torque or the sigma tau equals 0 to this one, how do you take the T value, the tension value? Anyways, you are asked to find the tension. You have to take the tension for the consideration when you are calculating. How do you take the T value? Like if I take the pivot point here, now I have to take the rotations, right? Bro, pivot point isn't pivoting there. No, it's fine, right? So if you have to take the rotations now, how do you take the T value?
Break down the
Yes, you can take this T value because it's in an angle of 30 degrees. So usually when you are taking the moments, how do you take the force and the distance? When you are taking the moment, how do you take the force and the distance? Perpendicularly, you have to consider that. If the force and the distance isn't perpendicular, you can't take the torque, right? You can only take a torque when the force and the distance are perpendicular. If isn't, you have to take a what? Component which is perpendicular. We discussed this, right? Previously. Can you remember? Should I remember you that? Yeah, come to the previous parts. Where is it? Come these parts. Page number 9. It's the same page. Page number 9. We discussed these things. When you are taking the moment, right? When you are taking the torque, the distance and the force should be perpendicular, or else if it isn't perpendicular, if it is acting in an angle, what do you have to do? You have to take the perpendicular component of it. Yes? Now can you remember? Good. Right? You have to take the perpendicular, you have to take the perpendicular component of it. Right? So it's the same thing when it comes to this question. What do you do? That's why I told you like these simple questions, like when we were doing it, it was simple, right? It was simple. That we did that simple question is to answer these bigger questions. Now you don't remember it, right? That's a problem, right? So now here the tension is acting in an angle. What should we do? Can we take the moments of this? Can't. So what should you do? You have to take the component which is perpendicular to the distance. So which component should I take? Cos or sine? Ladies, tell. Cos or sine? Huh? Which one is perpendicular? The pivot point is here. So is this T sine or T cos is perpendicular? Huh? Brain is not braining. No. The boys already know. Is it sine or the cos? Yeah, Johan, tell. Sine. Why is it should be sine? Because the perpendicular force is sine, right? So because I am taking the pivot point here, the tension should be perpendicular to the distance, which is the away from the angle force or the component, which should be sine. So the component that I should take is this, because it is the only component which is perpendicular. So it is T sine how much? 30. Now you know all the forces. Now all the things are perpendicular and set well. So you have to find the tension. Do it really fast. Do it really fast. Did you understood it? Yeah? Sure? That taking the component perpendicular? Yeah. We did in the like the previous questions, we did it.
Sir,
Yeah.
other than middle legging 200 newtons may
Hmm.
I
Five.
cancel out
නෑ යා 5 meters වලින්
එතකොට යාට reaction tank එකක්
නෑ නෑ එයා weight එකනේ පල්ලෙහාට එයාට ඉන්නේ reaction එකක් આવුත් එයාගෙන් වැඩක් නෑ ඒතර weight එකක් නෑ වගේ wall එකට do the simplifying fast done did it again or is it in the book fine good nice 2250 yes super done finish shall I do it? How much? No, why don't? Yeah, Chamat, here. Nice. Right, now check this one. Now what happened to this guy, Little or someone from Paragal? Kautarana? What happened to that guy? He's satisfied with the oh, that's fine. Can happen. Right? But me can't be satisfied if he's doing my tutes, huh? If he's doing my tutes. No, you can make question tutes the correct. You are giving the question, don't give the question tutes, huh? Not allowed. Because that's not a nice thing. You can make question tutes then fine. එහෙනම් කපන්න. ඒ කියන්නේ එතකොට satisfy නම් කවන්න නැහැ. නැත්තම් අර මෙයාකින් භාගයේ
questions කරන්නේ අමාරුයි.
අමාරුයි කියලා. past papers කළාද?
ඔව් බාකිට.
past papers අවුලක් නැහැද?
past papers කරලාද?
past papers අමාරු නැහැද?
නැහැ කීකී past papers උත්තර වාරණය කරන්නේ.
පාස් පේපර්ස් ඔයගොල්ලෝ කරන්නේ?
ඔව්.
අමාරු නෑ නේ. I have nothing to tell about it. Listen. So you are taking the pivot point from here, A, and sigma tau equals 0 and 0 equals. You have to take the anti-clockwise rotations first. Now this is clockwise. This is clockwise. Only this one is anti-clockwise, right? So t sine 30 minus, take all the clockwise ones as minus values. So in 5 meters 200 newtons are acting. So 200 newtons in 5 meters minus, again 800 is acting in 10 meters. 800 newtons in 10 meters. That's all, right? So calculate the values now. T sine 30 is half, no? So T half or T over 2. 200 into 5 is 1000 minus 800 into 10 is 8000. So the value here should be 9000. So you take the minus 9000 here, it becomes plus 9000. So T half equals 9000, right? So T becomes make a T again 8 meters, ne? So 8 meters should also be there. Right. Now it cancels out 4, right? So 4T equals 9000 and T equals how much? 2250. Right? So that is the tension that will be acting in this cable, right? So what can you tell by doing the question? Like, if the weights are like 800 and 200 and there is altogether 1000 newtons, right? It is 1000 newtons. Now 1000 newtons of a weight, if we are to lift 1000 newtons of a weight, අර මං කිව්වා වගේ glass එකක නේ 1000 weight එකක් lift කරනවා නම් and you are lifting it with the cable angled in 30 degrees, the cable should be able to bear how much? 2250 newtons of a force. නේ මේක අපි මෙහෙම 30 degrees වල angle එකක cable එකකින් දානවා නම් මෙයා උස්සගෙන ඉන්න, so cable has to bear this much of a force, right? It's greater than the actual force acting downwards, right? නේ එන ඊට වඩා වැඩි ටෙන්ෂන් එකක් ගන්න පුළුවන් එකක් දෙන්න ඕන නේ. එහෙම නැතුව දැන් ඔයගේ ෆිසික්ස් එක දන්නේ නැතුව කවුරු හරි ගිහිල්ලා මේ ග්ලාස් එකේ weight එක 1000යි ඒ ඉඳ 1000ක ටෙන්ෂන් එකක් ගන්න පුළුවන් කේබල් එකක් දෙන්න කියලා දැම්මොත් මොකද වෙන්නේ? ආයි කෙලින්ම ෆ්ලැට් තමයි. හරි. That is where the knowledge comes, right? දැන් ඕගොල්ලෝ ෆිසික්ස් ඉගෙන ගන්න එකේ තියෙන වැදගත්කම තමයි මේක. මොකද්ද? You can have the predictions, right? Predictions ගන්න පුළුවන් කොහොමද? ඔයා මෙච්චර වගේ glass එකක් නම් උස්සන්නේ, even you can calculate it. මෙච්චර angle එකකින් නම් ඔයා cable එක ගහන්නේ. මෙන්න මෙච්චරක tension එකක් තියා ගන්න පුළුවන් cable එකක්. cable එකද?
ඔව් මොකක් හරි දැන් මොකක් හරි ලොකු මොකක් හරි එකට මේ දානනේ ඒකේ angle එක කොහොමද ඔයාලා?
ඉතින් ඔයගලංග ඔය මේ විකිනුත් පුළුවන් නේද? මොකද්ද? ඔයගොල්ලෝ මයින්නේ පාර මයින්නේ මොකද්ද? gadget එක? theater light එක. ඒ වගේ objects තියෙනවා. ඒ වගේ එකකින් මයින්නත් පුළුවන්. ඒ වගේම තමයි මයින්. එහෙම නැත්තම් heights වලින් මයින්නත් පුළුවන්. ඉතින් ඒ කියන්නේ trick දාලා නේ. trick දාලා මයින්නත් පුළුවන්. heights වලින් ගන්න පුළුවන්. එහෙම දාලා trick වලින් ගන්නත් පුළුවන්. අර වගේ objects තියෙනවා. දැන් apps එහෙමත් තියෙනවා ඔය වගේ angle mine. apps තියෙනවා වෙන මේ වගේ angle mine එක කියන්නේ ඔයාලට එහෙම height calculate කරන්න ඕන නම් ඒත් app තියෙනවා phone apps තියෙනවා ටක් ගාලා ගන්න පුළුවන් මොකෙන්ද right got it angle එකම ඉන්න right මේක හරිනේ now this question is homework label these things make a homework it will be same it has two unknown factors you have to find one and it's more like same like the previous question right and come to these two questions I'll be doing one question and the other one is homework, right? Select one. You are getting to select one. First one or second one? Second one. Okay. Yeah, the second one is harder. The first one is easy. Right. Okay. Right. Hari. Second one eකට එන්න. First one is really easy. So these doesn't have any moments. So you don't have to consider the torque. You can only like you only have to consider the equilibrium of forces. So what is equilibrium of forces if you are considering? That is upward forces should be equal to downward forces and the left hand to the right hand, right? So what's the business there? Right? What are you selling? Huh? Right? Now, bro, what's happening? No. Okay. Right. So 80 kilograms mean there's 800 newtons acting downward, right? And you take the two axes, that is the vertical axis, and this is the horizontal axis. So these are the two axes you have to give concern about, right? Because if the forces are acting in angles, you can't take it into the calculations like when you are considering the equilibrium. Because when you are considering the equilibrium is the vertical equilibrium and the horizontal equilibrium. So the forces, all the forces should be in the vertical axis and the horizontal axis. If they aren't, you have to you have to derive it, or you have to take the components of the forces acting in angles to the vertical and the horizontal axes, right? Make forces හැම එකම මේ vertical and horizontal axes වලට ගන්න ඕන simplify කරනකොට, right? දැන් බලන්න මේකේ එකම vertical axis එකේ තියෙන 800 විතරයි. All the other forces are acting somewhere else. What shall we do? Break down all the forces into components which are acting in the vertical and horizontal axis, right? එතකොට break down T1. Now before breaking them into the components, you have to have the angles. We don't have angles. Angles are somewhere else. What do you do? Take the angles. Now if this is 60, this also should be 60. And if this is 30, this also should be 30. Now you have the angles. Now break down the components. Now T1 has two components in the x-axis and the y-axis, right? So what is the component of T1 in the x-axis? Tell. T1 cos 60. The other way. T1 cos 60. Right. No worries, no worries. The other component of T1? T1 sin 60 acting upwards. T1 sin 60 upwards. Now you can cancel out the T1. We don't need it in there. What about the T2? Yes. T2 cos 30 is one component. The other component is T2 sin 30, which should add to the T1 sin 60 because they are in the same direction, right? Plus T2 sin 30. Now you can cancel this out. So all the forces are in the
අර මේ පැත්තට එන්නේ
කොයි පැත්ත මේකද? That's the ceiling. You don't have forces on the ceiling, only in the strings. Right? Tension. That is just a ceiling. You don't have to consider it. Right? So now you have all the forces in the axes. So consider the vertical axis. It should be under equilibrium. That means upward should equal to the. So tell me the upward forces. T2 sin 30 plus T1 sin 60. Yes, should equal to 800 newtons. And if I simplify it into values, sin 30 is half, right? So T2 over 2 plus sin 60 is root 3 over 2, right? Yeah. So root 3 over 2 T1 equals 800 newtons. That is the first equation we found. Now come to the second equation, which is the horizontal equilibrium. Now why is this correct? Now why is this formula correct? Considering the vertical equilibrium, right? ඒක ඕනනම් ලියන්න within brackets ලියන්න vertical equilibrium, right? Vertical equilibrium. එහෙම ලියන තරමට හොඳයි. Vertical equilibrium කියලා ලියන්න. මේ අපි consider කරේ vertical equilibrium එක. And now we are coming to the horizontal equilibrium. Right hand side forces should equal to the left hand side. Now tell me the forces T2 cos 30, right? T2 cos 30 should equal to T1 cos 60, right? T1 cos 60. Right. So tell me the values. Cos 30 is root 3 over 2 T2. Cos 60 is half, right? So T1 half. This is the second equation. Now we have two equations with two unknown factors, and you have to isolate one. You have to remove one of either T1 or T2. Yeah, to simplify. Because you have two equations with two unknown factors. So you have to remove one. T1 එක මේකද? එතකොට yes, you can do that. Oh. එහෙම නැත්තම් T1 එක isolate කරා නම් ලීසි. T1 එක isolate කරා නම් 2 to 2 cancels out. It's the same thing happens. The ආරම්භ කරලත් ඕකම තමයි වෙන්නේ. එතකොට T1 equals root 3 T2, right? Then අපිට T1 වෙනුවට apply කරන්න පුළුවන් root 3 T2 in the first equation නේ. ඒක ලියන්න. Applying T1 in which equation? Equation 1, right? මේ ආව equation 1 එකට apply කරා නම් හරි. එතකොට කොහොමද දෙන්නේ බලන්න? මෙන්න මේකනේ. Yes. T2 over 2 plus root 3 over 2 instead of T1. Now we are applying root 3 T2 equals 800 newtons, right? So simplify this. Root 3 into 3 is how much? Root 3 into 3? 3. So T2 over 2 plus 3T2 over 2 equals 800. Now we can add these two together, right? So that becomes 4T2. I'm sorry, 4T2. Even I was confusing. Because T2 plus 3T2 equals 4T2, right? It's 4T2 over 2 equals 800. Cancels out 2, cancels out 400, right? So T2 equals how much? 400 newtons. 400 newtons. Now how do you find the T1? T1 equals root 3 into T2. So T1 equals root 3 into T2. So T1 equals 400 root 3. 400 root 3 newtons. Got it? 400 root 3 newtons. Right, so long. What shall we do? Bagi. Morning, write the first half. Did you understand it? Yeah? It's hard. Yeah, it is hard. Questions are like that. It's hard. That's how it is. Questions are hard. So is the life, right? Huh? It's not. Life is hard. Questions are hard. So is the life. And life is hard. Life is harder. So if you listen to the Island Fest of this 2024 batch this time, what I think right? What did he say? He said like he did A-level physics calculations as well. Physics calculations as well. ET. He has done the A-level. Yeah, the A-level in the physical science stream, biology and physical science stream. They have followed the A-level physics questions as well. So, yeah. So he became the Island First anyways. So harder you try, the higher you can fly, right? Yeah. Done? The whole thing? How come? කරනකොට ලියුව? ඔව් ඒ කියන්නේ essay එකක් නම් කරන්න. essay එකක් වගේනේ මේ ගන්න මේ essay question එකක් වගේ ටිකක් ලොකු ගන්නනේ. අර T1 එක simplify කරලම් තියෙන එක හොඳයි. මට ඔය simplify කරන්න බැරි හින්දා මම ඔහම තිබ්බේ. search වලින් තිබ්බේ. Yeah. Just a second. Wait a second. Yes. What are you eating? Yeah. What? Eating bunnies? What? Bunnies. Bunch degree one. This one. Root 3 into root 3 is 3 ne? So it's 3 T2. එතකොට මේකේ අපිට ඇඩ් කරන්න පුළුවන් නේ? පුළුවන්. එතකොට 42 over 2. So 2 to 4 cancels out. ඒකත් එක්ක මේ 2 එකෙන් මෙයාව divide කරා. 800. After the class. After the class. මට දැන් චුට්ටකයි කතා කරන්න. Right. So listen, these few questions are homework. Label this one. Question number 12 is homework. Do at home. Question number 13. These two questions are homework. And here listen, this question, label the forces. If A and if B. This is F A, this is F B. It's the same like the previous question. A with them. Eh? Edging again. Edging mean. Yeah.
අර උඩ පොල් එකට දැන් මෙහෙම දෙකක් ගහලා තියෙනවා. ඒකේ මේ පැත්තේ මෙහෙම තියෙන පොල් එක පොඩ මෙහෙට එනවා.
ඔව්. වැටෙන වෙලාව.
එතකොට මොකක්ද වෙන්නේ?
එතකොට ඒත් බැලන්ස් එකේ තියෙනවා. But at a certain point it can drop.
මේකනේ මේ forces දෙක මේ මොකක්ද වෙන්නේ කියලා. support එකට increase වෙනවද decrease වෙනවද? මේක කොහොමද මේක increase වෙනවා. මේක decrease වෙනවා.
Increase and decrease and මොකක්ද කියන්නේ?
ඒ කියන්නේ දැන් මෙහෙම පෝල් එකක් තියෙනවා.
ඔව්.
ඒ දෙකට මෙහෙම මේව දෙකක් තියෙනවා දෙපැත්ත.
හරි.
මේක x මේක y තියෙනවා.
හරි.
ඊට මේ y එක මෙහෙම පොඩ මෙහෙට ගත්තී.
හරි.
මේ ෆෝස් මේකට සපෝට් එකක් වෙනවද කියලා අහනවා. මේකයි මේක. x එකයි y එක.
යට තියෙන සපෝට් දෙක ලඟ වෙනකොට පෝල් එකට සපෝට් එක වැඩි වෙනවද අඩු වෙනවද?
අඩු වෙනවනේ. සපෝට් එක අඩු වෙනවා. ඒ කියන්නේ
මේක මෙහෙටදී අඩු වෙනවනේ.
ඔව්.
අර ඉතින් වැඩි වෙනවා.
සපෝට් එක
තියෙන එක වැඩි වෙනවා මේක නැහැ. ඔව් මේක ඩික්‍රීස් වෙනවා මේක ඉන්ක්‍රීස් වෙනවා.
question එක ගන්න. ඒ කියන්නේ ඕකේ අර center of gravity එක මෙහාට යනවා. ඊට පස්සේ ගොඩාක් ලං වෙනකොට ආපහු ආපහු වැටෙන්නත් පුළුවන්. ඔව් වැටෙන්න පුළුවන්. Send me the question. Now listen, next question, this one also may become homework. Yeah, these two, 13, 1 and 2, homework. Then the question number 14, this is also homework. Make a liagana friction between the ground and the ladder. Yeah. Friction coefficient, not friction coefficient between the ground and the ladder. Friction coefficient between the ground and the ladder. Mu equals 0.2. क्या दागा? Ground එකයි ladder එකයි අතර friction එක mu friction coefficient එක mu equals 0.2. Mu is the friction coefficient. We still couldn't discuss it. Next week we discuss karenge. Right? So that's the end of the workbook, and we'll be discussing the theory part, the theory tute next week, and we'll be finishing force and question stick karanna orderly ekay, and when make a bala so this one, right? Hi. Bro, what has happened? No signals. Source 1, right? Yeah. 2 ekada. Dhammawadi? Yeah. This one. Yes, listen. Right, so this is a stimulation of an elevator, right? Now listen. Now this is going to go up, right? So we discussed the system, systems about we discussed about the accelerating systems, right? So this is the guy in a elevator, right? And now the weight acting downwards and the reaction force are same, 700, right? 700 and 700. And when it's moving up in an acceleration, right? Now here the acceleration is still 0. What should happen when it's accelerating upwards? Which one increases? Which is increasing? W or the reaction? W or the reaction? Bro, tension is නෑනේ මේකේ. එනම් මම මේකත් එල්ලෙන්නවා. ඒකේ එල්ලිලා ඉන්නවා. ටෙන්ෂන් දෙකක් තමයි. ඔව්. කොහමද එන්නේ? Reaction. Normal reaction. Reaction nigga. Actually it's a reaction is changing. Now look at this. Look at this. Listen. Now the velocity is 4 ms minus 1 and it's I think still bro listen. Now it's 4 ms minus 1 and it's this can't do it, right? So what that yes. Mental tension that's a different case. belly වැරදාගත්තාම ඒ කියන්නේ ලනුවෙත් වෙන ටෙන්ෂන් එකෙන් තමයි අර මේ ස්පයිනල් කෝඩ් එකනේ කල්ලෑනේ ස්පයින් එක කල්ලෑනේ ඒ පැත්තෙත් ඕනනම් අර පැන්ක්‍රියස් එක කල්ලා යන්න පුළුවන් පැන්ක්‍රියස් එකනේ මොකද්ද මෙතන තියෙන්නේ ට්‍රැකියා එකනේ ට්‍රැකියා එක කල්ලා යන්න පුළුවන් අර මේකට තද වෙනවානේ I think the real thing is like මේ ස්පයින් එක කැඩෙන්නේ I tried it. Huh? එතකොට ඒ කියන්නේ හුස්ම ගන්න බැරුව මැන්නා කියලාද කියන්නේ? දන්නේ කොහොමද මේ ටෙන්ෂන් එක එන්නේ මං හිතන්නේ ගොඩක් වෙලාවට වෙන්නේ මේ ස්පයින් එක කල්ලා යනවා ඇත්තේ. නේ? ඔව් ටෙන්ෂන් එක එනවනේ මුළු ඇඟේම වේට් එක බෙල්ලට එතකොට. ඈ? Practical එක කරමු. කවද්ද? yes. විශ්වාස වෙනකොට පුළුවන්. ceiling fan වල සීලින් ෆෑන් වල මේක හයියයි මේක අර හුක් එකක් දාලා එල්ලලා තියෙන්නේ. ඔව් අර යකඩ හුක් දෙකක් දාලා එල්ලලා තියෙන්නේ. Bro, that's depending on the person. No, not the person, like the on the situation. Like rust වෙන එක වෙන්නත් පුළුවන් නොවෙන්නත් පුළුවන්. Depends. රස්ට් වෙලා තිබ්බොත් ඉතින් උගේ ලක් එක. මේකට සාමාන්‍යයෙන් යකඩ හුක් දෙකක් දාලා නේද මේක එල්ලන්නේ? මේ ෆෑන් එක නිකන් එල්ලලා නැහැනේ. යකඩ හුක්ස් දෙකක් දානවනේ. අර කට්ටියනේ දැන් මේ යකඩ ෆෑන්ස් වල මේ ෆෑන්ස් වල එල්ලලා මැරනවනේ. ඔව් මේක හයියයි. හා ඕනම් බලන්න පොඩ්ඩක්. ආර දාලා තියෙන්නේ. එළියෙන් තියෙන්නේ. ඔහොම තමයි. හරි. Now look at the simulation. දැන් acceleration එක කීයද? 2. right? m is minus 2. බලන්න එතකොට reaction එක මොනවද වෙලා තියෙන්නේ? reaction එක අඩු වෙලා. හරි. මේ කියලා තියෙන minus velocity එකේ. මේක going up එක අපිට going down කරන්න පුළුවන් නේ going down. දැන් බලන්න. හා? මේකද? අපි උඩින් ඉන්න පල්ලෙහාට ගිහින් මෙයා. බැයිද? Going down. Play. Come down. Reaction time එක? Reaction time එක? Reaction force එකද? ඈ? අපිට මේ calculation එකෙන් තමයි හරියටම බලන්න පුළුවන්. අපි පොඩි වෙලාවක් අරගෙන ඕන calculation එක බලමු. අනේ next week බලමු. Next week මම calculation එක කරා. මේ calculation එකෙන් හරියටම බලා ගන්න පුළුවන්. Right guys, then see you on next week. Shiny, see you on next week. Johan. කෑල්ල අයින් කරනවා අපත්